Hello all. That today's lesson is lesson number 6, and this is your industrial application of DC motor. Already the fundamental things already we know, and the characteristics we detailed explained in the previous classes or previous lectures. If any doubt in the previous lectures, you can comment and you can ask. Okay. Now come to the industrial applications. Now, when we are discussing about the characteristics of DC motor revision, so if you will see something brief, we I am just discussing that series motor exhibits the high starting torque and variable speed drives, you can say, okay, suitable for the traction system. What is the relation we obtained there? The torque, if you will write the relation, then one relation is coming from this point. That is torque is directly proportional to the Ia square, because here the flux is directly proportional to the current in series. Okay, that's why we are getting the high starting torque for this series motor. Similarly, short motor have nearly constant speed at varying load. We solve one characteristics, that is your constant speed drive. That constant speed drive, we can see that torque and the relation torque and speed is directly proportional to the power. If you are making the um, speed is constant, then that is no relation with the torque. Okay. Then what will happen if you will plot the graph? What we are plotting, that torque, any condition of the load, whatever, if you will vary the load also, the speed can't affect. Speed is constant. Okay. Then next we will come to the compound motor. Compound motor is a combination of both shunt and series. And what will happen? The characteristics of the speed mm, versus your current, can say that torque versus current, and your mechanical torque versus speed. All characteristics are improved by using the compound motors. Okay. But now we are discussing about the applications of DC series. DC series motor more suitable for both high and low power drives. Okay. For fixed and variable speed drives. This type of motor has a simple construction because all the components are connected in series. This is very simple in design. And here you can say that armature current equal to load current equal to the series current. All currents are also equal. Okay. Then we can use for the high power drives, for both high and low power drives. Any place you can use. And also it is easy for the design and maintenance. Okay, design, why it is easy? I told that it is simple in construction because all the parameters are connected in series. Because of high starting torque, this motor is used in cheap toys and in automotive applications such as cranes, air compressor, lifts, elevator, winching system, and electric traction. Okay, lots of examples are there. When you require more static torque to drive a machine, then you can go for this series. Okay, then comes the next, that application of shunt motor, and here the DC shunt motor provides the constant speed operations. Okay, if it is provide the constant speed operations, then you can say this type of mostly used in constant speed application from no load to full. Okay, that is your wiper and automatic windscreen, drills, conveyors, fans, then boring mills, then shapers, blowers. Okay, where you are getting the constant speed operation, you can use the DC short motor. Okay, because drills, just an example I am giving. Conveyor, that is the example. That is constant speed is only required. Otherwise, what will happen? Variable, due to the variable speed, whatever it can break. For this region, this is also the constant speed drive applications you can use. And here also another possible thing is that it's a adjustable speed drive also possible in a case of the DC shunt motor, that we discussed now, constant power and variable speed, and variable speed versus the constant. There is two conditions in adjustable. If you see that constant speed and variable power, another one is your variable speed and constant power. These are the conditions of supersede in case of DC short. Now applications of the compound DC motors we will see. As we discussed, there are two types of compound DC motors are there, and one is a differential, another is a cumulative approach. Cumulative compound motors. The differential compound motor has poor torque, okay, characters, because the motor increases the speed with increase in load, right? So the motor is not suitable for any practical applications. This differential, but the cumulative compound motor has high starting torque characteristics, and any high starting torque where it is required, also it has a good speed regulations. Okay, then we can say that the cumulative compound motors are widely applicable as compared to the differential compound motors. What are the examples? You see that presses, electric salves, reciprocating machines, conveyors, stamping of machines, elevators, like this. Then what are the summary? You can see the DC motor are used where variable speed and control, various speed control and high static torque. This, okay, where you require the variable speed control and high static torque, then you can go for the DC. Then commonly applied in electrical traction system like trains, trams and electric vehicles. Okay. And similarly other type of like shunt motor is applicable for the constant drive, and you can see it is also utilized in means a lot of advantages and disadvantages we discussed in these lectures. Now on the come to the problem number one. In problem number one, what I want to tell you, when you are how to start one problem. This problem, first you see the which type the problem is. If the type is mentioned, it is very good because we know the diagrams, we know the circuit diagram, we know the parameters, what are the included in this type, and most important thing, we have to write down the given data. Any type of question when we are starting, then first you write down the given data. Everybody first read carefully the question and write down the given data. First, we'll write this. Here you can see, first if I will start reading from here, a 4-pole DC shunt generator. That means one is your generator type is written as a DC shunt generator. Okay. In case of this DC shunt generator, the connections already we understand, and here this means the field winding and armature winding are connected in parallel. Okay. If this field winding and armature winding are connected in parallel, then we can draw the circuit diagram. But first of all, we write the parameters. You see a 4-pole DC shunt generator. Pole number is given 4. Shunt resistance is given, RSH is given 100 ohm. Okay, unit is very important. and armature resistance equal to your 1 ohm, right? Then has a 378 wave connected conductors, that means Z equal to 378 it is given. Then next is wave connected. In wave connected means we understand that the number of parallel path equal to number of pole. And how much the number of parallel path is? Pole number is given 4. That means number of parallel path is 4. Then the flux for pole also given. Flux for pole means flux is given 0.02 Weber. If load resistance is 10 ohm, load resistance equal to your 10 ohm. Is connected across the armature terminal, and the generator is driven at speed n equal to 1000 rpm. Calculate the power absorbed by the load. We have to calculate the power absorbed by the load PL. Formula will be VL into IL. These parameters we have to compute. This is the question, all about my question. Now we will go to the next to solve this. First, we will draw the circuit diagram of this DC shunt generator. Then only we can solve it. First, when we are drawing the circuit diagram, first we have to place the armature winding like this. There is one EMF is induced process, and there is one field winding. Okay, and these two are connected to the load, means that the values are given. Now we will mark what are the values. Load resistance is given here 10 ohm. Armature resistance is given is your 1 ohm. And the shunt resistance it is given, I think it is your 100 ohm. Okay. And EG you have to calculate because it is not given. And brush voltages are not given. Due to the brush voltages are not given, that means VB equal to negligible. Right? Now come to the next. We just you see the armature winding. If we will mark there is 2 points here, A and B. This is the armature winding, and this point is the C and D. Both are connected in parallel, and of course E and F also connected in parallel. That means suppose due to the generated EMF, the IA current, here I am different color to identify. I am using, see here. Suppose the IA current is flowing here, then something ISH shunt current is flowing here, and load current is flowing here. That means the summation we can write here that IA is nothing but equal to ISH plus IL. As it is connected in parallel, then also we can mention that VCD equal to VAB equal to VEF. That is your load voltage, right? Load voltage. But all the values are not given. If the parameter is not given, what to do? We will keep as a load voltage like this, and we can solve this. But see the methods. Then when I'm talking about VCD, V equal to VF and VL, and this equation already we know, that can I say that how to find out your ISH? When I will find out your ISH, can I write that your voltage drop across CD by your RSH? And here you can see the VCD is nothing but equal to VL. Then I write VL by RSH. Similarly, in case of IL also, that is nothing but your VEF by your RL. Then VEF equal to your VL. Can I write VL by RL? These two we can write simply because as it is connected in parallel, this is the condition. Now you put in this current equation, so then you can also compute the IA current. IA equal to VL by RSH plus BL by RL, that means BL 1 by RSH plus 1 by RL, like this. And all the values are given. This VL can write 1 by 100 plus 1 by 10, then approximately it will come 0.11 VL. Okay, this is the value. It is coming like the IA value is coming 0.11 VL. But as we don't know the VL, one thing we can do, mm, we can relate this one to any other equations. But you see, when I will use this color now, suppose we know that here that the armature voltage drop VAV, we can say VEF means load voltage. Now we can derive the armature equation as VV is negligible. I am just neglecting the VB term, right? Then if we will do this one thing you see, armature voltage drop, how to find out? That is the generated EMF minus IA into RA, right? Is equal to your, that we know. And in this condition, RA value is given, EG value we have to calculate. It is not, it is also given. How? Because you know that EG formula, that is nothing but your P phi NZ by 68. So that is formula. P value is given, that is 4. Phi value is given, that is 0.02. And N value is given, that is 1000. Then Z value is 378 divided by 60 into 4. A equal to P. Wave winding, that means 4. Then 4 is cancelled out. Then if you will solve this equation, the answer will come 252 around, it will come. The Z will come 252. Then you can keep 252 here, and here if you are putting this 252 EG value, IA value we already computed, that is 0.11 VL into 1, because armature resistance is your 1 ohm. Then you will put, then it is equal to nothing but VL, right? Now Now you see that 252 can I write that is VL plus 0.11 VL, right? That means it will come around, the load voltage will come around 252 by 1.11. Then approximately it will come as 2 sorry 227.0. This I already calculated. Okay, then BL you computed. Okay, our objective is to find out the PL. Then how to find out the PL? PL is nothing but your VL into IL, right? If your VL you already computed this is the value, okay, then you can easily calculate your IL. Otherwise, you can rewrite this formula in a different way. That is, you can put VL square by RL. You can put here. Then VL square means that is your 227.02 whole square, by your RL value is 10. Then answer will be coming as 22.70, or something it will come. You can, sorry, the answer will be coming as a 5.5 0.35. This is the all about your answer. Means initially you have to write down the current equation, okay, but the values are not given, the voltage values are not given. For that, what we just find out the relation that all voltages are equal. From these voltages, first find out the shunt current, load current. Then if we'll add, then we are getting some relation, that is armature current is nothing but you are equal to 0.11 VA. If we are getting the armature current, there is a relation will come, that if we compare the armature voltage drop as well as equal to the load voltage drop, Then there is a formula will come Eg minus IARA equal to VL, but Eg value we can calculate by using the given parameters, because Eg formula we know Eg equal to P5 NZ by 60A, then you can easily calculate that is the value is 252. Already we computed the IA value, then put IA value and solve it. Then we are getting the actual load voltage. If load voltage is given and the load resistance is given and question asks to find out the power, then what is the formula of the power? Power equal to VL into IL, means load voltage into load current. Then if in place of load current, because RL value is given, then can I write VL by R? That means what will happen, VL into VL, that is VL square by RL. Then already the VL is computed from this 227.027 whole square by 10. Then approximately it is coming 5.5.35. This is all about the answer. Now this is the second question. In this second question, you just see, first you write down the types and the parameters. In problem number 2, you see the type. The type is already written as DC long DC shunt, uh, long shunt DC generator or long DC shunt generators. Okay. Then a load current is given. Load current is given 200 ampere at a terminal voltage of 500 volt. VL is given 500 volt. The resistance of the armature RA value is given, that is 0.03. Series field, because long shunt means series resistance will come, that is equal to 0.0154. Then another one is your shunt resistance. Shunt resistance equal to your 150 ohm. These are all about the parameters given. Calculate the EMF induced in the armature, assuming the brush drop of 1 volt per brush. Here brush voltage given, and we know that there is two brushes we are using. That is your B1 and B2. If 1 volt per brush means that two brushes means total voltage drop equal to 2 volt. Okay, keep in mind that always in the DC generator, if two brushes we are using, the total brush drop voltage equal to 2 volt. Now we can easily draw the circuit diagram. The circuit diagram is a combination of series, armature resistance, then brushes like this, and we can connect the shunt resistance, the potential when connected to the. Okay. Now you see here, the load current is given is how much? That is 200 ampere. I'm using something different color. Then load voltage is 500 volt, right? Series resistance is your given 0.015, and the array equal to 0.03, right? Then what will happen? Your shunt resistance is 150 ohm. Gross drop voltage VB is given equal to 2 volt, and you calculate the EG. How to calculate? In this circuit also you see the same shunt. When exam maximum the shunt questions are coming, because series is very simple questions. That's why we are solving only the shunt type of questions. And here you see what we are just putting the terminals A, B, C, D, and E, and right. Now you see the same, if the IA current, if I put some IA current direction is this one, then IA current is divided into two parts. We know that, that is your ISH and IL, right? And IL value is given, VL value is given. That means in if we will write all the voltages VAV equal to BCD equal to E, and all the voltages are equal, that is equal to 500 volt. Then can we easily we can calculate the shunt current, because load voltage is required means what is the shunt current value, first calculate. That is your 500 volt load voltage divided by 150. What is the value it is coming by using this calculator, because I have not solved this one. Then 500 divided by 150, it will come around 3.33. What is ampere? Okay, one part of this problem we calculated ISH equal to this one. That means IL also given 200. Then can we calculate, because we know the formula, that is IA equal to IS plus ISH plus L. Then can we go to the next and I will solve this one. That is circuit diagram. Do you remember that circuit diagram? Then directly I am correct. IA equal to ISH plus, right? And if better to, we are doing the drawing diagram here again. It is good for you. RA, then RAC, then not drawing fully. The slide it is there. Only I am doing the like this. You know, for your understanding. And here we already put that IA. IA we have to calculate because ISH we already calculated, and here IL already given, that is 200. ISH is your 3.33. Okay, that means IA it is easily we can calculate, that is 200 plus 3.33. That is your 203.33, right? The IA current if you will derive, now it is not much more difficult to calculate the generated EMF, because you see I kept here the points A, B, C, D and EF. Okay. Now one condition is just write down, that is your VCD equal to VEF, right? Now in case of VCD, what we will understand, that is your if I am talking about VCD, then first write down the formula. That is formula is EG minus IARA minus IA into RSE minus VB, because gross voltage in the question it is given, minus VB is equal to your load voltage. Load voltage is 500 volt. It is given. Then you can use this EG. We have to calculate EG as a EG. Then minus 2 volt for VB. Then we can take common, that is otherwise we can also take common minus of IA. Then RA plus RAC equal to 5, right? Then we solve this equation to find out this one. EG equal to 2 plus IA is your how much? 200, 203.33. RA value is given as RA value. RA, that we have to see RA value is 0.0, sorry, 0.0, okay, 0.03 plus series value 0.015. This is the plus 500. It already there. The total value is coming around 572. 572 is the answer. And total EMF generated across this armature. This is the one, the another type of. Now we'll